Yes, sir. Good morning, everyone. My name is Pontu Mande. Today, I am going to introduce some of the topic on flight. Basically, the aerodynamics of the flight. It is a very vast topic, but I am going to show some light on only the flight, which is related to the flight of the aeroplane only. So let's start. So going to the history in 1903, the Wright brothers invented and flew the first airplane, and it is recognized as the first sustained and controlled flight. As we know that the first the flight was invented by airplane was invented by the Wright brothers, and that time they have invented the manned flight, which don't have much machinery installed in it, but it is basically the phenomenon which is common in all the flights which are from the history to the current. All the flights are based on the same phenomenon, which is airfoil system. Uh, the when there is a only four force responsible for the flight. So let's start. So four forces of flights are lift, thrust, drag, and weight. Lift is the force which acts on a airplane on upward direction, where thrust is the force which acts on forward direction, and which opposes the drag force. Drag force is basically force generated by the airplane, and thrust is generated by the engines such as the jet engine, uh, various, and the weight is the our gravitational force. So let's understand every force basics. Lift is the force which is produced by the wings. It is the mechanical force generated by the solid object moving through a fluid, and the lift is based on the Newton's third law of motion. That is, every action has its uh, reaction pair. So as we when the airplane is moving in a particular direction, then it needs to oppose the air, and while opposing air, it should uh, exert some equal and opposite force. So when these action are taking place at a time, the wings such as wings exert a force which opposes the drag force, and this drag force causes a lift, which we will be seeing in our next slide. So our wings are of airfoil shape, and while cutting these wings from this side, we get this shape, and this shape is named as the air foil shape. Now going to start how it actually works. When the air goes through the airfoil shape, it get pushed up. Hello, sir,
Yeah.
is it visible?
Yes, yes.
Now I am going to share a video which shows how the wings generated the lift. So here is a small video. This is the part of the airfoil shape which going in the opposite direction of the wind, opposite direction of wind. As there is a collaboration of wind on the wing, that is airfoil shape, and it gets uh, generates some lift, which causes the lift motion of the air, which lift motion of the whole aircraft. And at the particular the counter the angle which the air strikes on the airfoil shape is called as the action of is called as the angle of attack. If we increase the angle of attack, then we generated the more lift. So by increasing the angle, there is a generation of lift, but we should it increase up to the certain angle. While going to beyond the certain angle, it should increase the drag, we can by which the airplane will not generate the more lift, and it will uh, it will be starting to it will be getting slower. Now the other force which are responsible of the flight is thrust, and thrust is produced by the engine. In the image we are seeing the engine which produces the high amount of thrust, which is responsible for the motion of the aircraft in forward or backward direction. As this thrust, as this engine starts, it increases the backward force. So by the action reaction pair, if we it backward force is increased, so airplane get start motion moving forward and with a high speed. And here is the drag force, which is also responsible for the flight of the airplane. It is basically the air resistance. It is basically the air resistance, and also drag force is generated by the engine. So all these forces, combination of forces, is necessary for the airplane to be flight into the sky. If these all forces are balanced, that is weight is balanced by the lift, and thrust is balanced by the drag, then we are able to stay the airplane on the particular height, at above the sky. If the one of the forces is missing, that is, or one of the forces get unbalanced, then we will get some variation while flying. That is, we are uh, and weight is the force which is balanced by the lift. It is the basically the gravitational force. And when the gravitational force is increased than the lift force, then that is weight. If weight is greater than the lift force, then plane start descent, or we should increase the first lift force to get climb into the sky. Now the conditions for the flight: if the lift is greater than the weight, then flight rises in the sky. And if weight is greater than lift, then it falls. Not saying generally falls, but if we want to get land on the track, we should decrease the lift. Various phenomena are used to decrease the lift, such as we need to increase the track uh, so that the thrust decreases, and we will get a soft landing. And if the thrust is greater than drag, then plane accelerates. And this is condition we need uh, for initiating the flight action. And drag when drag is greater than a thrust, then if plane slows down, which is required for the landing. So uh, so all these forces are needed for the aeroplane to stay in the sky. And I'm trying to search some quoted on this. That is the for a plane to be rise in the sky, we require slip force is must be greater than the weight. In similar way, for a person to rise in a life requires efforts should greater than excuses. Thank you for giving me opportunity. Thank you, sir.
Okay. Before I say something, comments from you people. Go ahead one by one. You can raise your hand or you can speak directly, or even you can type in the chat box.
Sir,
Yeah.
is my screen still visible?
No.
Yes, sir.
Okay. Karan says very nice presentation. Okay.
Thank you.
Excellent presentation.
Excellent. Okay.
Thank you, Ajay and Karan.
Good. So whatever we are discussing yesterday and day before yesterday, so he has used all the things optimally. So he has optimized the text. The text was not too much or too less. The images were very proper. Speaking speed was quite okay. Even if you slightly decrease the speed, that is okay. But it happens. It will take time, and
Sir, should
slowly.
I share slide again?
Yeah, go ahead. So overall, it is quite close to 100%. But I would like you to point out uh, any points to improve.
Yes, sir. Fluency in English. Very bad, sir.
Yeah. So saying good, nice, it's okay. That is very simple. But you should tell Pawan
Yes,
that
sir.
where he can improve. Anyone?
His fluency better by just holding it up. Or
No, I didn't get it.
he was fumbling, sir, little bit.
Okay. Yeah, fumbling was there, but it's a part of practice. So certainly he can improve it.
Yes,
Yes, sir.
sir.
I'll take care of it. Thank you for
Great
complimenting me.
presentation.
Sir, question.
Yeah.
Sir, question.
Yes, I do have a question.
Pawan, can you hear me?
Yes.
Uh, we all know that air is a
One, can you
fluid.
open the slide again?
So when plane,
The angle one, the angle slides.
Which one? Third?
Yes.
Is it? Hello?
No, no. The just two slides before. You're going down, boy. Go up.
Previous. Yeah.
Yes, yes, yes,
Forces of light? Hello?
yes, yes.
Yes, you can ask.
So my question is, what is the acute angle between the chord line of the wing and the direction of the relative of the wind?
Chord line? No, I don't know much about it.
Yes, it do will have an acute angle.
Yes,
My
sir.
question is,
Yes.
while holding the direction of the relative wing, what will be the angle of?
I am not understanding your question. Can you please elaborate?
I want to say that what will be the acute angle between the chord line of the wing and the direction of the relative wind? Whether it will be angle of altitude or whether it will be angle of attack.
It will be the angle of attack. No, you are talking about
How so?
are you talking about the at which angle the
Yes,
wind
when the wings will oppose each other with wind.
see if when the wind attacks on on a airfoil shape, then it will be the angle of attack. Hello, hello, am I audible?
Are you satisfied, Rajat?
Hello, hello,
You are
sir.
audible, Pawan. Yeah, you are
Yes,
audible.
yes, sir.
Basically,
Rajat.
this is what it is called as fluid dynamics. Okay. So here the air is considered as fluid. Air is also a fluid. Air flows, so that is considered as fluid, and water is also fluid. Okay. So in second year or maybe I don't remember exactly, maybe second year or third year, you are going to learn about this fluid dynamics in depth. There is one complete paper of fluid dynamics. So that is really interesting. And there is some principle called Bernoulli's principle. We learn about Bernoulli's principle
Bernoulli's of principle.
in depth. Yeah. So that is how it gives the lift. And Therefore, the shape of the aeroplane is designed in that particular fashion so that it gets minimum air resistance. But also at the time of landing,
Sir, it do act on Coanda effect and Newton's third law.
yes, of course, Newton's third law is there because if you want to move forward, you have to give the
And
force.
sir, Coanda effect.
Which one? Which
Coanda
effect?
effect,
For na?
which drags and holds it back.
Yes, of course. All actually this is very complex motion. So everything related to drag, the friction, air friction, fluid dynamics, everything will come into play. Newton's third, the first law, second law, third law, everything will be there. So we consider one at a time. So like Newton's third law, to every action there is equal and opposite reaction. Okay. So you are taking the action by forcing the air to go back, and that air or the reaction force will push that aeroplane in front forward direction. Also for the lift, so weight will be balanced by the lift. Okay. And then you have to talk about the center of gravity also, center of mass, center of gravity, both. So this is a very complex part, but in general, certainly aerodynamics is really important. But at this moment, we don't need to go into much detail. Overall, Pawan has presented very nicely. Uh, Humbling, yes, it takes time. Even we are now almost teaching for 20 years, but sometimes it happens with us also. It's okay. It's not something that you can avoid 100%. It's okay. Quite close to what I was
Yes, sir,
expecting.
Pawan's presentation was
As,
quite good.
yeah. As far as first year is concerned, very nice. Very nice.
Thank you, sir.
Okay. Any other question? Has anybody experienced traveling through the airplane?
Yes, sir, me,
Ah, good.
while I was small.
The most beautiful moment, what I understand, and that is my opinion, when it takes flight, थोड़ा सा जमीन के ऊपर जाता है ना, that is really beautiful.
Yes, sir. That's the
And then
blistering moment.
लैंडिंग के टाइम में अगर आप फॉर एग्जांपल यू आर लैंडिंग इन सिंगापुर और हांगकांग, it appears like you are going to land on the sea surface. So it's horrible sometimes. Okay? But it's good. It's good. और वो जो फिन्स जो है वो जैसे वर्टिकल ऐसे ऐसे वर्टिकल हो जाते हैं ना, ऑलमोस्ट वर्टिकल. ठीक है, so that the drag will be more to stop the aeroplane. So that is really beautiful to see. If you are quite close to the wings, then you can see it very clearly. ठीक है. So keep looking the engineering everywhere, everywhere. Even at your home, you can see the engineering. Okay. Okay. Let us go to next participant.
Tejas.
Yeah. Tejas, you can share your screen. Pawan, you can stop sharing and keep the recording on.
Yes, sir.
Sir, me?
All the best stages.
Yes. Okay, sir, I will start now.
Yeah.
Is my screen visible?
Yes, I can see you are sharing. Okay. The screen looks very small.
Yes,
Okay, Tesla. Can you make
sir,
it
it is visible.
bit? Yeah, it is visible, but it is not readable.
ऑटो रोटेशन ऑन कर.
Okay. Check the auto rotation. Ah, now it's okay.
Okay, so good morning, everyone. My name is Tejas, and today we are going to learn about Tesla coil. A Tesla coil is an electrical resonant transformer circuit which is used to produce low voltage current, high frequency alternating current electrical. So, when and who invented? Tesla coil was invented by Nikola Tesla in 1981. He was born on 10 July 1856 and ethical served in the village of Smijan. He is one of the greatest scientists who introduced induction motor. He was the first to introduce hydroelectric power plant, and he is also responsible for the alternating current power. And he is one of the father of the radio communication. His vision. Now here we can see when the Craft Tower, which was also known as the Tesla Tower, was invented in 1901. His vision was to transmit wirelessly power throughout a particular area through which he can transfer wirelessly power to ship boats and aeroplanes. The second image, as you can see, he was vision to plant several towers so that he can wirelessly transfer powers throughout the world by using the multiple towers. But due to some financial issues, and it was not possible to transfer wirelessly power due to its electrical discharge, it was failed. So how it is made? As we being an engineer, we are always curious to build something. So it is very easy to build an Tesla coil at a home. You just need a copper circular wire and a resistor, BJT, and a MOSFET. First, we have to wrap the Tesla coil in a wooden block, cardboard in a circular coil. Then, of course, we will need a external power supply to run. So, how does it work? As here we can see three images. First, an external 220 volts AC is applied to the charge. Then the current is passed through an BGT where a spark gas is stored. In second images, the spark is happened and the current is transmitted through a primary coil. The primary coil is charged and the current charges are passed to secondary coil. The secondary coil, in the third image you can see the secondary coil create a loop. This loop is open loop by which at which the range by which we can charge any object. The merits and demerits of Tesla coil. First merit is we can control power by alternating currents. The charging, slow charging after the spark gas fire. It performs an excellent load sharing. Demerits are the more complex and small circuits are required. Large DC sometimes capacitor is needed. High voltage, high inductance of charging is needed, and current run is non-sinusoidal. Interesting facts about Tesla coil. We can connect to MIDC device. It can create music. MIDC is an software by which we can amplify as being a property of a resonating. It can amplify and by the sound we can get interesting sound. So the world largest Tesla coil was it's about 60 feet. 1 It can generate 1,30,000 watt unit and its range is 12 kilometers. Variation used today is in television and radios. Used in future technology. As we all know about the company named Xiaomi is a multinational electronics found in April 2010. They are adapting for a wireless charging technology by charging through air. It it by uh, by applying antennas at phones several, it can catch the ions and can charge the phone through air. So at last, a quote by Nikola Tesla: "I have not failed. I have just found 10,000 ways that won't work." Thank you.
Okay, good. Any
It
comments?
was
You
an
can go
impeccable
to
presentation, Tejas.
Awesome, sir.
What?
slide
It
number
was an
one.
impeccable.
Mm, sir, 1 second.
Yeah.
Okay. Yes.
Okay. Is that electrical resonant transformer circuit?
Yes, that was.
I think there is a spelling mistake there.
Yes, sir. I type it on my own means.
Okay. So that should be corrected.
Okay, sir.
Yeah. Next slide. Okay. Any comment on this slide?
Actually, sir, it's more, much of history in physics.
Mm-hmm. So he should have reduced it, or what you suggest?
I think it's good.
Okay. Any other? Okay. Whenever you talk about the slides and you show either 2 or 3 images or 4 images, then the sequence should be ideally from left to right. Okay. So you talk about first Nikola Tesla. Okay.
Yes.
So you should show the picture first. Then you
Okay.
talk about his birthplace. So instead of this right hand side picture, the map should be
Mm-hmm.
there. And then you talk about the application. So this application should be at the bottom. Are you getting my point?
Yes, sir.
Okay. So whenever, I mean, not only for Tejas, but whenever you prepare these kinds of slides, so if you are taking, say, 3 or 4 points or images on the same slide, which ideally you should not take. You should take at most 1 or 2 images, not more than that. Okay. You could have put these applications on next slide. स्लाइड ज्यादा होगी तो कोई प्रॉब्लम नहीं है, लेकिन एक स्लाइड पे इतना मटेरियल होना चाहिए कि वो दिखना चाहिए. अभी मोबाइल पे तो मुझे ये पता ही नहीं चल रहा कि क्रोएशिया कहाँ पे है. ठीक है. So that should not happen. So you can make images much larger. बहुत ज्यादा बड़ी हो गई तो भी चलेगा, कोई दिक्कत. छोटी नहीं होनी चाहिए.
हाँ सर.
Uh, uh, you should always think about left to right and top to bottom. So once you finish the first line,
Sir,
जैसे
can I
आप heading
ask
कर
one
रहे हो,
question?
yeah, go ahead.
Actually, Tejas, though it was an impeccable presentation, what is the principle behind Tesla coil?
What is
Principle behind
principle
it.
of?
Principle behind Tesla
Oh,
coil.
हाँ.
On what principle does it work?
Hmm. Tejas, got his question?
can you repeat question? Uh, it's a to achieve a phenomena which is called resonance.
And how does this resonance takes place?
Sir, when primary coil shoots the current into the secondary coil, the
You can
lifetime of maximum.
you can go to that slide and then explain.
Sir, can I change?
Yeah, yeah. Good.
Sir, may I change?
Yeah, yeah. Go ahead. First, clear his question. Yeah. First, clear his question. Then we can come back.
Okay, so yes, Rajat, are you there?
Yes,
Hello.
I am there.
Okay, so your question were on
Yes,
what
I'm there.
principle is behind Tesla coil.
Yes,
So
yes.
in this image, I can't zoom it. Can you zoom the image?
Yes, yes. Sure.
Take get to the second image.
Yes, now I've zoomed it.
So
Yeah, got it.
it is depend on the phenomenon of resonance. So can you see the primary coil?
Yes, yes.
There is primary coil and a secondary coil. So the current is shoot to the primary to secondary, and just the right time to maximum energy is transferred to the secondary coil. And due to this transferring,
Yes, yes. Now got it.
an open loop is created. In that open loop, it contains ions in that area. If we bring a light bulb, it will glow.
And one more question, though nearly every part of Tesla coil is capable of giving a lethal shock while the system is operating, shock or not, either it will kill or not.
Mm, Many times it may be not lethal, but if you insist on getting, so
Many
you
times, but
can.
it may harms you.
Uh, Not much.
It is because the the voltage of this circuit is very less.
Yes,
Current is
yes.
high. Current is high,
High current, low voltage. Yes, sir.
low voltage.
Right. Yes.
It can
So that is
maximize up to 10
much
ampere.
less, but certainly you have to take care when you are talking about kiloampere current. So certainly it will be a lethal weapon or lethal thing uh, if you touch accidentally for high
Yeah, yes.
current, high current. Normal this small uh, household what he has shown, what he has prepared. Okay? So that is not lethal.
Yes, yes, sir. Sir, it's just a small.
Thank you, Tejas.
Yeah. Basically, it is just accumulation of charges. You are just
Yes.
accumulating the charges at certain places, and then suddenly this charge will be discharged through certain system. Like if you touch, then maybe your hairs will
So then how many
go
resonant
this
circuit can we take?
pardon?
How many resonant circuits we can take? Two or three?
Resonant circuit, you need only one resonant circuit. Why you need more resonant circuit? You mean for higher voltage?
Yes, sir. For wireless connection, we do need a high voltage.
No, basically this device is low voltage, high current. So if the voltage is high, then it is risky. Remember, high voltage is always risky.
Sir, it is a step-up transformer came in place here.
Yes, sir. Catch it.
Ah, so then you can use different type of now you are using this transistor. Why you are using transistor?
Sir, are you asking me?
So we won't get shocked.
I can't see the transistor in the circuit where it is
Yes, sir. Me too.
because I can see only LC circuit.
Sir. Sir, it got. May I show again?
Yeah, yeah, go ahead.
Just now let's going back to the future.
Hello, sir.
Yeah.
Just in future, it is possible to have a wireless connection without getting
Sir,
any harm.
sorry, sir, I got disconnected. Since I got a call.
Okay, okay. Um, no, because since we are talking about electromagnetic waves, um, more strength. So if the strength is increased, then certainly it will affect our health. Even right now, the strength is quite less, but still the health is affected. You can see the sparrows are now, crows and sparrows are hard to find.
Yes, sir. Because of the radiation, many sparrows and things are dying.
Right. So this
If
Tesla
wireless
sound is
connection comes to our
more
grid,
health.
then we can get.
Yeah.
Thank you, Tejas. Now my doubts are clear. You can get hold of.
Yes, it's appreciated.
Okay. So Tejas, I hope you got the my ideas how to present
Yes,
it.
sir.
So remember
Yes, sir.
always, all of you remember, since we are talking about English language, left to right and top to bottom. That is what the sequence should be. So if you want to write, say 1, 2, 3, 4 on the presentation slide, then one on the left, two on the right, three on the left bottom, and four on the right bottom. Okay, that should be the sequence.
Okay, sir.
Clear? Okay.
Yes.
Next, next is next.
Yes, sir.
Next presenter.
Sir,
Yeah.
sir, was the recording disconnected between session?
No, it is still showing recording.
Yes, okay, sir.
Sir, I want to present my 50.
Okay. Go ahead, Karan.
Sir, we have an GD today, so that's
What time?
maybe
12:15.
12:15.
Then Karan, how much time you will take?
So let him present. We will wait. We have 1:30 lunchtime, so let him present.
Okay, okay.
More than sir 10 minutes.
More than,
Sir, can you take the attendance first?
I think
Less than.
let let us go for Karan's presentation tomorrow. Okay, we'll have special time, and then we can take the presentation. Since tomorrow, I think we don't have any lecture, right?
Yes, sir.
Okay, so because you should get slight break also.
Okay, sir.
Pawan, you can stop the recording.
Yes, sir.
and you can send it to me.
Sir, indeed, today's presentation was much good.
Which one?
Both of them.
Yeah. Uh, I must appreciate you people as far as first year is concerned. You are preparing